So last piece of the review for us, experimental design, how to set up a good experiment or sample method. First thing we take a look at are the different types of sampling. The first, simple random sample, the best way to do sampling is essentially that all individuals would be given a number, and they're going to have an equal chance of being selected. So we'd randomly select out of that. Everybody gets a number. Everybody has equal chance. Um, an example of that, so maybe all students at Gibbons given a number, and we would use a random number generator, right? The random number generator. And using that random number generator, we would select 25 random students. A stratified random, we'd be broken into some group. There's some defining characteristic about the group, and you take a simple random sample within each group. So a good example at a school, we'd randomly select, we'd break it up by class, 20 freshmen, 20 sophomores, 20 juniors, maybe to take some type of survey for us. A cluster sample, the one that most people kind of forget about, here you're going to randomly select a group. Randomly select a group. And then survey, observe, do the experiment. We'll just go with survey right here, but all members of that group. A great example of that at a school is we'd randomly pick a room. So let's say we pick, room 105, and then we would give it if we have a survey, and survey all students in that room. A convenient sample, probably the least effective. It is the worst way of sampling, but it's probably the most often used, unfortunately. A convenient sample is basically you survey who or whatever is convenient, is closest, or convenient, right? So, good example of that, if you're trying to do a survey about something at school, you would just, ask your friends, because that's who's around. A teacher, maybe a teacher's trying to find the average GPA of the students, so they just talk to the ones in their particular class because those are the people that are right there with them. A systematic sample would be where you ask every, nth person, maybe measure every sixth tree in the forest. So for us, maybe we stand at the door and ask every 10th person that walks in the front door. So the problem with some of these sampling techniques, systematic, convenience especially, is you get some of these issues, especially under coverage or non-response. If you only ask your friends, then they're more than likely people that are very, very similar to you. Let's say I teach an AP class and I survey my AP class for average GPA. Well, I get a pretty bad undercoverage there because there's a good chunk of seniors that maybe just take honors or do the CP level stuff. So undercoverage and non-response, what we're going to do is we're going to miss parts of the population. Another issue in sampling is voluntary response, especially if it's something convenient. Maybe people that stop you in the mall. A big one, radio stations say call in, tell us what you think. Is typically what you're going to do is you're more likely to get likely to see the extremes. You're not going to see people down the middle. Bias can be introduced based on wording of a question. Right? How a question is asked could definitely affect whether or not someone will respond positively or negatively. Do you think we should be sending soldiers to war where they will be killed? Like that's a pretty significant bias in that question toward the negative. Versus, maybe somebody asks a question, do you think that we should send soldiers to war in order to ensure freedom for other people? That's a positive skew to that. So you got to be careful how questions are worded. And so you could potentially interact with a AP test question that has something to do with the wording. One thing we need to make sure we're aware of, the difference between experiment and observational study. In experiments, you're given treatments. The parts of an experiment: randomness, replication, and control. So one of the big things, again, this is a thing that separates experiments and studies, is control. And with control, really what you're doing is you're considering aspects that could affect results that you don't want, or that you're not accounting for. So in other words, those aspects aren't part of the experiment. Randomness is always important because it's going to reduce, you could potentially say eliminate bias, but if you don't get to pick who gets what treatment, then there's no bias there, right? So if a doctor knows a patient is really sick and is part of a study, if the doctor is aware that, they're about to go on the placebo, right? If the doctor gets to pick who gets the medicine, who doesn't, then all of a sudden a bias has been introduced by the doctor. Replication is important. It'll help to ensure significance. Right? It's a lot more significant when there's an average drop, a big time average drop in blood pressure for 1,000 people on this new drug versus 2 people. So that's where replication comes in. We want to make sure that we either repeat the experiment a few times, or we just have a big sample size, which has been one of our conditions throughout the class. I mentioned before, randomness helps eliminate bias. Another thing is blinding, and basically what we're looking at there is subjects would be unaware of their group. Are they getting the placebo? Are they getting the treatment? And that's important because obviously if somebody knows they're getting the placebo, they're probably not going to take it. Double blind means that the researcher also is unaware. So somebody knows who's getting placebo and who's getting the drug, and eventually the researcher will find out. But this could be important. Like I said, the doctor example, if the doctor knows he's giving someone the placebo, it might affect how the study is done. Blocking was an important concept that we talked about, and basically what that's just going to do, we're going to separate, it'll use these homogeneous groups, these groups that are the same, and what that does is it's going to reduce the effects of some type of lurking variable. I know the AP test loves to do something where a farmer's planting crops next to a river, and so in order to account for the effect of the river, you'd have to set up your block accordingly. You'd have a block next to the river, a block a little bit further away from the river. I've seen questions, something with windows, So blocking, you just want to somehow set it up where you already know there's a variable, and so you're going to account for that on the front side. The 2 types of lurking variables, and really if you have trouble differentiating between the 2 of them, you could just refer to them both as lurking. But a confounding variable, so we see this relationship between x and y, but a confounding variable all of a sudden is another one that could also account for what's happening with y. One thing, maybe, a study I've seen in one of the released questions, they took a look at whether or not people ate apples and if that led to cavities, right? So apples would be your x, cavities would be your y. Well, a confounding variable here, z, could affect, the people that eat apples might also just have a healthier lifestyle, which could reduce their number of cavities. Common response is one, so Z could affect both of those. A good example here, you know, uh, more people are swimming and more people are eating ice cream. So does that mean swimming leads to ice cream consumption? Well, no. There could be this lurking variable, and in this case, it's common response of the temperature. When it's warmer outside, more people swim, more people eat ice cream. So a couple examples really quickly to kind of pick through this. The dog food company wants to compare this new food with the old. There's 30 dogs, 10 small, 10 medium, 10 large. And the company is going to supply the owners of each size dog with the two foods. And the owners have agreed to not feed their dogs anything else. This is important. This is a measure of control, right? That's one of the issues. They're controlling for diet. Another form of control, excuse me, is this idea of blocking. Obviously, different sized dogs will have different responses. So what we're going to do, there's the 30 dogs. We're going to block by size. So we'll set up these blocks. We'll take 10 small, 10 medium, 10 large. Now we need to account for randomness, right? We need randomization. Well, so far we can't randomly assign them to their size, but we can randomly assign which food, right? So maybe we give each dog a number, the number of the small dogs 1 through 10. We'll pick 5 unique numbers to get the new food. The remaining 5 get the old food. Same for the medium. 5 will get the new, 5 will get the old. Same thing here, 5 new, 5 old. Well, we also have the idea right here. This would be our randomization step. And then from there, like I said, so we're talking replication. So the replication, there's multiple dogs that get each food. Sorry, it's kind of hard to read that small writing. Now don't forget, at the end of your experiment, you need to come back. You need to compare the weights, obviously. So if you have to design an experiment, this is a good way to kind of set that up. Label in the steps along the way, and you might have to actually write out, hey, here's how I would do it randomly. Just give some detail. Make sure you account for, how things are going to fall into their different groups. Here's another example. Manufacturer Boots wants to conduct this experiment. Company recruits 100 volunteers in Seattle. Okay, there's a form of control right there, right? There's some control. Seattle. So essentially, most of the people are going to be exposed to the same kind of day-to-day life in terms of the climate. So they're going to wear the boots normally as they would for 6 months. And at the end of 6 months, the boots will be returned, and they're going to kind of test new versus old. Well, there is, right, they can randomly, we got to figure out some way to do randomness, and the replication obviously is going to be taken care of with 100 people. But the trick here is, how are we going to randomly assign what happens? There is a lurking variable here, and I'm going to say that's going to be their job. Some people's jobs put them outside a lot more than others. So what's going to be important is, if random assignment was just who gets the new waterproof or who gets the old, we could run into the situation where all the new waterproofing is on people that are indoors, and then all the old is on people that are outdoors. So a way that we can eliminate this is the idea of a matched pairs. And what we could do, we take our 100 subjects, and our random assignment, we could split it up. 50 will get the old on their right foot, and then the new will be on their left boot, and then 50 people will get old on their left foot, new on their right. That way, the boot is exposed, the new and the old is exposed to the same wear and tear in both situations. So the random assignment here would be to randomly assign, who gets which one. If we know, what their job typically does for them, maybe we could block by job type, how often they're outside. But there's one potential way that we could set up that experiment. And one more example here, a company is concerned about stress, so they introduced two programs, yoga and Tai Chi, to help reduce stress. They've got a group of volunteers, and they're going to do it during their lunch hour for a 10-week period, and they're going to be randomly assigned to their group. So there's randomness, randomly assigned to a group, and then they'll have their stress levels measured at the beginning and end of it. So Part A asks us, a group of volunteers who work together ask to be assigned to the same program so they can work together. I guess they get along well, maybe, and they maybe want to do the same program. So a potential problem with that, though, is if they're in the same work group, they could have the same work stress. So perhaps, overbearing boss. So that group could be overly stressed, or that's kind of the negative side, but maybe they're really, really laid back because their job is, maybe really easy within the company. So when they're all from the same group, that means they're all exposed to kind of the same stresses. So kind of the same stress for that group. And so that could affect, coming into it, they could be more stressed to begin with. So it'd be better to kind of spread those folks out, and hopefully randomness would do that. Someone says, hey, maybe a control group should be thrown in here. And the beauty of a control group would give you that baseline of stress levels. As is, we can only see if Tai Chi is better, is better or worse than yoga. Is it doing better? Is it doing worse than yoga? We don't actually know if either one of them reduces overall stress level there. We don't know if either reduces stress level. Right? One thing to consider too, chances are if these people are volunteering for this study, maybe they already enjoy Tai Chi. Maybe they already enjoy doing stuff like this. So this would, be one of those lurking variables. Their enjoyment of it could cause the stress to drop a lot more. And it could just be the activity. Instead of the actual yoga lowering the stress is being lowered because they're doing something they enjoy. And then is it reasonable to generalize these to all the employees? And that's why. No, because the volunteers, they are lurking variables. They most likely, they enjoy these activities. That's why they volunteer. So the findings, they're kind of compromised here in that setting.